So what's the big deal about files? Well, files are where we store most of our data. We don't enter it from the keyboard. So we're going to store it in a file, usually called a database or something like that, and then we're going to bring it in, process it, and then put it back out. So that's what files are used for. So these are the objectives for our chapter. When we work with files, we're usually talking about input and output. Here we're going to use our data, use our program to create data, and then we would use another program to maybe process it. So in previous programs you wrote data that was stored in variables. Well, that's exactly what we're doing here. The file input and output can interact with various types of applications. So for example, you can have your data interact with word processors, image editors, spreadsheets, games, web browsers, all kinds of things. So what are the steps in working with the file? Well, number one, we're going to open the file. That's the big picture. And so we open the file, which means we're creating and preparing it for output. So an input file means opening and preparing a file for reading the data. Then we're going to process the file. So let's say that we actually have a file here. We're going to pull it in, and then we're going to process it. And then we're going to write it back out to a file, and then we're going to close the file down. You have to disconnect the program from the file. Let's go into detail on this. There are two kinds of files that we usually work with. The first one is called a text file, and that's where the data has been stored as regular old text, and we can read it as ASCII or Unicode, and basically it means even numbers can be stored in a file. The second kind of file is a binary file, which includes data that hasn't been converted to text. It looks like ones and zeros. That's how it got the name binary. And usually a text editor is required to figure out what the contents are. One other thing we need to know about input and output files is that there are two ways that we can go access that file. Number one is called sequential access, and that's where data is accessed from the beginning to the end. All the data must be read. The second kind is called direct access, or also called random access, and it's where any piece of data can be accessed without reading all the data that came before it or after it. In this chapter, we're basically going to look at sequential access files. We're going to create a file and write data to it. So number one, the file that is created should be given a name with an appropriate file extension. So we would call it something like customers.dat, where the .dat represents a general kind of data. Number two, we must also create an internal name that is similar to the variable name. So for example, we might declare output file based on customer file. So here's our customer.dat. And we're going to have that related to the internal name, where output file indicates the mode in which the file will be used. It's an output. And customer file is the internal name used to work with that file inside the program. Number three, files must be opened first of all. So we're going to open our customer file. That's the variable where we're going to store all the stuff. And we're going to get it from customers.dat. That's the real name of the file that we're going to draw from. Data can then be written to a file. So if we were going to write to it, we might say write customer file equals Charles Pace. All right, so that's in quotes. That's a piece of data. That's a string. Or we might say something like declare string name equals Charles Pace. And then we would write customer file name, which would in this case be the variable, which is populated by Charles Pace. Now lastly, we have to close that file out. We're going to go out there and close the customer file. A couple things about the structure of that data. First of all, there are things called delimiters and EOF markers. A delimiter is a predetermined character or set of characters that marks the end of each piece of data. So in many cases it's a comma, or it could be a semicolon. Basically it separates the different items stored in a file. However, the EOF is a marker or a set of characters that are written at the end of the file to mark the end of all the data. Let's look at reading data from a file. An internal variable must first be created and declared. So we would do something like declare input file, inventory file, where input file indicates the mode in which the file will be used. Inventory file is the internal name used to work with the file. All right, once we've declared that variable, then we can open the file. And we might do it with something like open inventory file, quote, inventory.dat. Now, inventory.dat is actually the name of the file that you would see if you looked in the folder. But inventory file is the internal name that we're using in the program. Number 3, the data can then be read. So we might have something like read inventory file, item name, where item name would be the name of the field that we were actually reading. That would be the variable name. And then finally, we would close it. So we would close it with a command like close inventory file. Fairly simple. Now, we have a thing called the append mode, which is actually, in addition to the reading and writing mode, you can append files to an existing file. So if an existing file already exists, it won't be erased. It won't be overwritten. But if the file does not exist, it will be created. And then when the data is pulled in, it's added to the end of the file that you want it added to. Most of the time, in working with large databases, what we're going to utilize is looping to get all the data in. So here are 2 different ways to do that. Pause the video and see if you can figure those 2 out. As you can see, and it's very evident, oftentimes files and arrays work really well together. So the contents of an array can be saved to a file. So at that point we would open the file, we would use a loop to step through each element of the array, and we'd write the contents to a file in each iteration. So each time the loop went around, it wrote one more piece of data to the file. You can also read data from the file into an array. So for example, you would open the file, you'd use a loop to read each item from the file, and you would store each item in the array element. Cool. So turn to page 395 and do review questions 1 through 9. Start the video up when you finish. Now, turn to page 397 and do short answer 1 and 2. So what does a record really look like? Well, this is kind of what a record really looks like. It's a whole set of related data about a certain item. So in this particular case, we've got 3 pieces of data in the record. The name field is populated by Ingrid Virgo. The ID number field is populated by 4587, and the department field is populated by engineering. That would be one record. When we process records, we basically do 2 things. We can write records, so the entire record is done by writing in a single statement. So we could say write employee file, and then we would say name, ID number, and department as the 3 fields we're actually writing to. If we're reading records, we would do the same thing. We would say read employee file, name, ID number, and department. Algorithms can also be used for adding records to a file, for searching for a specific record, for modifying a record, or deleting a record. Turn to page 397 and do Algorithm Workbench number 1. In working with files, we have a thing called a control break, which is something that allows us to stop the process and intervene so that we can actually see what's going on. And the easiest way to demonstrate this is to show you. So if we said our screen holds 24 lines of data, we can say, okay, if lines equal to 24, in other words, when the count gets up to 24, then press any key to continue, and then expect an input of any key to continue. And you've seen this so that we can actually look at the list and it doesn't just scroll by so we can't read it at all. Here's our sequence in review. You ready? We're going to give the file an internal name inside the program. Then we can open the file with one command. Then we can populate an array with a while do loop using EOF. Don't forget to count the records as they come in so you know how many you have in that array. You may not fill the array, but at least you'll know how many you have, because we're going to need that later. Then we would process the records in some way. We do a count or whatever we're going to do with our program. Then we can display the data using a for loop, using that count as the sentinel value. And then we would finally close the file. And speaking of closing the file, we're done.